Hi all. So today we are going to solve this question, minimum operations to make a unique value grid. So in the question you are given a 2D integer grid of size m cross n and an integer x. In one operation you can add x or subtract x from any element in the grid. A uni-value grid is a grid where all the elements of it are equal. Return the minimum number of operations to make the grid uni-value. If it is not possible, return -1. So you are given this 2D integer array, and you need to either add or subtract x value, and so that all the value becomes equal. So there is nothing special about 2D here. It could be 1D also, right? If you want to make all the value same, then it's better, right, to sort the array that we have got after transforming into 1D. So here I have taken one example where it's more of a skewed values, like I'm trying to put more larger value on the right side to get some observation, like to identify which should be the target element where all the elements should reach in minimum number of steps. So here assuming x equal to 1, if we try to make all the elements equal to 1, so what are the changes that we would need? So here the this element would need 1 step, this would need 4 steps, this would need 5 steps. This is 99. This is 499, right? So if we go to any of the middle element, if we go here, then this would need 4. This would need 3. 3 plus 2 is 5. And this is 0. So, and this one is 1. This one is 95. And this is 495. And if we try to go here, like, or make all the elements as this one, select this as target element, then 0 here, 400 for this. Then this is 494. This is 495. This is 498. This is 499 for one, right? So you see, as we move to extreme, we have more elements to change, right? More elements has to go to their extremes. Similarly, in this case also, there are two elements. Uh, these are the larger values, right? So more element has to move towards more drastic values. And if we move to some of the middle elements, then there is a balance in change. To balance it out, the differences, we can either select the middle element, any of the middle element. And yeah, that is one very good observation, and this solves our problem. As in, we will select directly either of these two elements, or and try to make uh, all the target element as same to calculate how many steps are needed. So these steps would be simply the target element minus the array of that index, this absolute value of this, and divided by the x. So this is the number of steps that we need, right? And we can simply add it into our result. We can simply add this to our result. So yeah, yeah. Let me walk you through the code, and this fairly simple implementation. It is so yeah. This is the code here. In the first step, we are basically converting this 2D into a 1D array, and we are sorting this array, and we have selected the target element as the middle element, and here this is the difference between all the elements. We have to take the absolute difference and check if it is not divisible at all. It means that it is not possible for that element to become target. So it is not possible to make the elements target or the array as equal. Then we will directly return -1. Otherwise, we would add the steps needed. So this is the steps needed, where step is difference by divided by the x value that we are given. So this is it. Hope you like the solution. end the video. See you in the next video. Thank you.